Welcome, AP Psychology students. This video is going to talk about Module 63 and 64, and really the theme, when it comes down to, is the biological and environmental factors that relate to intelligence. So really the whole nature-nurture debate, so should be interesting. When we talk about the research on nature and nurture, we kind of start with some of the studies on genetics and intelligence. And so I'm going to show you a graph here in just a minute. But, one thing sometimes people ask, is there an intelligence gene? Well, there isn't one gene. Researchers believe intelligence is based by many genes, so they call it polygenetic, poly meaning many. So we'll look at twin studies, we'll look at adoption studies. So one thing, when we look at adoption studies, we see that if children that are adopted, their intelligence scores on these tests, the older they get, tend to look more like their biological parents and less like their adoptive ones. So what we see is kind of this strength towards the side of, the role of genetics and intelligence. They're both, both sides are important, but definitely genetics, which sometimes gets overlooked. And we'll talk about this term, heritability, as well. So heritability, kind of a confusing term for some people. So if you look at that first bullet point, the extent to which genes can explain differences in groups regarding a certain trait. So it's not simply how much of your intelligence is due to genetics. It's how much of the difference within a group of people, let's say Americans, how much of the difference within the population is due to genetics. So if we look here, we see that if 99%, 96% falls between 70 and 130, that's a large chunk of the population. So if we said, hypothetically, that intelligence was 50% heritable, we're saying within that 60-point span, about half would be due to genetics. So things that are, things that are highly heritable are going to be things where the environment is very similar, but we see differences. So things like, you look at like height. Height is extremely heritable. I have a younger brother, we grew up together. I'm 5'5", he's 5'10". So we could say that that 5-inch difference, high rate of heritability. If you have two siblings and they have, they're related in every way, same, parents and everything, and they have different color hair color would be highly heritable. So what we see with intelligence, according to the research, is an estimated heritability somewhere between 50 and 80. That is a big span. So what I would take away from that is probably half or slightly more than half of our intelligence is, and when we say intelligence, we go back to all those questions we've been talking about. What is intelligence, etc.? So we just said performance on intelligence tests, slightly over half is genetic. That leaves a lot of room for environmental factors, by the way. So we look here. This is the chart I was kind of talking about. So if you see, didn't mean to do that. You might have part of this cut off at the bottom. So on the far left, so these are correlation coefficients between different levels of siblings. So on the far left, it says identical twins reared together. So these are identical twins that, were raised in the same home. We see a correlation coefficient of their test scores of about a 0.86, I believe. If you remember your correlation coefficients, that is very high. Basically, according to the researchers, two identical twins taking an intelligence score, if you study a lot of them, that score is basically what they call it, a carbon copy. It's basically like two different people. It'd be like this. it's like the same person taking it twice, basically. That's what I meant. So very similar in intelligence test scores. So this would also translate over to things like, ACT, SAT scores. Usually if you ask identical twins, their scores are within a point or two, if not exactly the same. Grades are often very similar for identical twins. We'll get into this in the development chapter too, but a lot of times when I talk to twins, identical twins, they say their first word on the same day. Most of their physical milestones, like rolling over, taking their first step, oftentimes same day. So genetics definitely do play a role. To the right here, it says identical twins reared apart. So here we have a correlation coefficient of about, I think it was a 0.71. So it's lower than a 0.86. So this we would say is entirely due to environmental effects. Same DNA, same genes, but they're not growing up in the same house. So it is lower. Here you see fraternal twins. So these would be twins that, genetically are the same as just regular brother and sister, but they were born at the same time. We see a correlation coefficient of a 0.6. So again, a smaller correlation than identical twins, either of the identical twins. So this shows that genetics, again, play a huge role. This group, identical twins, but they're raised apart. These are fraternal twins, born at the same time, but still a smaller correlation than the group that was raised apart. These are just regular old siblings raised together, even smaller, kind of a meager 0.46 correlation. And these are just any two unrelated individuals raised together. So you see here that both genetics and environment play a role. This chart would probably lead a little bit more to a genetic cause. So you can see here on the slide, basically the gist of it here is the closer the genetic relationship between two people, the higher the correlation, according to people who research this. And again, adopted children are more similar to biological parents than adopted parents. This was kind of like when we talked about weight and body size. It was the same kind of thing. So again, they both matter, but genetics oftentimes get overlooked, but they do play a role, a very strong role. But that being said, some of the environmental effects, the book will go a little more in depth if you want to get the details here, but things like, if you look at the Flynn effect, a big part of that is the fact that we have the opportunity to have better nutrition today. Not everybody takes advantage of that. We have better educational opportunities. I often tell my classes, my parents, they went to, Des Moines, Lincoln, 1960s, early 1970s. I think they graduated in like 72. The highest math class they had to take to graduate, Algebra 1. Think about, you guys take that, 8th grade, maybe 9th grade, I don't, whatever. There's, more demands on kids today to achieve academically. We probably push you a little bit further than, 40, 50 years ago. So that plays a role. Poverty, coming out of poverty would help, with intelligence levels as well. At least it appears to correlate with that. School matters. The book talks about some early childhood education programs like Head Start, which basically, they set up shop in more impoverished areas or areas that have more at-risk kids, and they try to do things to keep those kids from falling behind, because oftentimes by the time those kids get to kindergarten or first grade, they're already significantly behind kids who've had a little bit better home life that would contribute to having higher intelligence scores. So doing things that at a young age to try to keep those kids from falling behind, that helps as well. This Rosenthal-Jacobson study, I don't think that's in the book, or if it is, it's not talked about much, but basically this idea of teachers having high expectations for students. Basically, the gist of the study was they had these researchers come in and they told the faculty at this school, like, hey, we were looking at test scores and other things, and we identified this list of kids who, according to our research, are ready to blossom academically. You just gotta, you gotta keep an eye on them. And what we found was, not we, but what they found was that those kids, oh, and by the way, all of the data they were showing to the faculty was just made up. They just wanted to see what would the impact be if we told teachers, like, hey, keep an eye on this kid, push this kid, they're ready to show some growth. So what they found at the end of the year is those kids, by and large, did show growth compared to the kids that the researchers didn't identify. So the point was, if the teachers had an expectation, like, hey, this kid is ready to blossom, I'm going to push this kid, I'm trying to get the most out of them, then it tends to lead to, a larger growth versus kids who had not been identified. So the point is, if teachers can have high expectations, give a lot of attention to students, that seems to make a big difference. So I think, intuitively, I think we all know school matters, so I like to think that. But this is one example of a study that really demonstrated that. You could see in the chart that I showed you that fraternal twin scores scored more similar than regular siblings. The reason that relates to environment is, if you have a fraternal twin, you're born at the same time versus, let's say you have a younger brother or sister who's 5 years younger. Yes, you grew up in the same house or whatever, but it's not exactly the same. So, you guys all know that, parents change. They might parent one kid different than the other, and, maybe the parents get kind of soft in their old age. And so 5 years can be a big difference, in an age gap in how those parents treat those kids versus two kids that are born at the same time. It's in both, it's a similar environment, but with the fraternal twins, it's a more similar environment. We talked about having a growth mindset with the video on grit, and if you believe that you can get better, that goes a long way versus if you think like, oh, well, you're either smart or you're not. Because even if you're smart, you can always get better. The way I like to think of it really is, the genetics probably set the ceiling, but the environment probably determines whether you reach that or not. And you can see here things like motivation, grit is pretty much as powerful. In some studies, they've said more powerful in determining academic success, job success, as raw IQ scores. I think that's a good place to stop. I've been going about 12, 13 minutes, so I'll kind of split this up into another video. So thanks for listening, and bring any questions you have to class, and we'll talk to you soon. Thanks, guys.